honor darles la bienvenida a las Jornadas Científicas Inria Chile 2023. Este evento ha sido organizado por Inria Chile en colaboración con la Pontificia Universidad Católica de Chile, la Universidad de Chile, la Universidad Técnica Federico Santa María y la Universidad de Concepción, y con el apoyo de la Agencia Nacional de Investigación y Desarrollo, ANID. Comenzaremos con esta primera jornada hoy, aquí en la Universidad Católica. Mañana martes estaremos en la Universidad de Chile. El día miércoles continuaremos en la Universidad Técnica Federico Santa María en Valparaíso y el día de cierre estaremos en la Universidad de Concepción. Estos 4 días tendremos una oportunidad única para compartir conocimientos, explorar colaboraciones y destacar avances significativos en el ámbito de las ciencias digitales. Damos así inicio a este evento que promete ser enriquecedor. Les informo que el idioma oficial del evento será el inglés, por lo que continuaremos en dicho idioma. Good morning to all distinguished participants and panelists. It's a honor to welcome you to the Scientific Days Inria Chile 2023. This event has been organized by Inria Chile in collaboration with Universidad Católica, Universidad de Chile, Universidad Técnica Federico Santa María, and Universidad de Concepción, with the support of the Agencia Nacional de Investigación y Desarrollo, ANID. We begin this first session today here at the Universidad Católica. Tomorrow, we will be at the Universidad de Chile. On Wednesday, we will continue at Universidad Técnica Federico Santa María in Valparaíso, and the closing day will be at the Universidad de Concepción. Over these 4 days, we will have a unique opportunity to share knowledge, explore collaborations, and highlight significant advancements in the field of digital sciences. Now, it's my honor to introduce the welcome words of Aysén Echeverry, the Minister of Science, Technology, Knowledge, and Innovation of Chile. Unfortunately, due to unforeseen circumstances, the Minister is unable to join us in person today. However, she has sent us a video message to share her greetings and insights. Let's now turn our attentions to Minister Aysén Echeverry video message.
Buenos días a todos y todas. Quiero aprovechar esta instancia para saludarlos en la inauguración de las Jornadas Científicas Inria Chile. Sabemos que esta será una semana llena de discusiones muy interesantes, multidisciplinarias, en distintas áreas del saber, del quehacer científico, y donde esperamos puedan llegar a buenas conclusiones. Como gobierno estamos trabajando de la mano con Inria y el gobierno francés para potenciar las capacidades en inteligencia artificial y también profundizar la colaboración científica tecnológica entre nuestros dos países. En ese sentido, para mí es un honor poder participar de esta inauguración y les deseo todo el éxito en estas jornadas científicas durante la semana.
Thank you, Minister Echeverry, for sharing your insights and vision with us today. Now, I leave with you Mr. Pedro Buchón, Vice President for Research at the Universidad Católica, as our host for the first day of Scientific Days. We warmly invite him to share a few words of welcome with us.
Muy buenos días a todas las personas que hoy nos acompañan, especialmente al señor Philippe Vinogradov, encargado de negocios, interino de la Embajada de Francia en Chile, al señor Jean-Frédéric Gerbeau, que je vois ici dans l'écran, que vous êtes déjà ici, Jean-Frédéric, a la señora Nayat Sánchez-Pi, directora de Inria Chile, señor Pablo Barceló, profesor de la Facultad de Ingeniería y host de la primera sesión, y al señor Philippe Preux, equipo Proyecto SCU del Centro Inria de la Universidad de Lille, que nos acompaña. Nos sentimos muy orgullosos como universidad hoy día de que se estén inaugurando estas Journées Scientifiques Inria Chile 2023, acá en el campus San Joaquín de la Universidad Católica, y encontramos que este es un motivo de mucha alegría para nosotros y un privilegio que podamos inaugurar estas sesiones acá en nuestra universidad como símbolo de la solidez de la colaboración que tenemos entre Chile y Francia. Hoy contamos con la presencia de investigadores de Francia y de Chile. Hay una delegación francesa importante para poder desarrollar las 4 jornadas, ¿no es cierto?, que hoy día nos señalaban, y que permiten también una interacción importante de Inria Chile hoy día a través de la participación de 8 universidades socias principales, un número importante. Y en este sentido, estas jornadas tienen el desafío de poder relevar la investigación que se hace en conjunto entre todas estas instituciones, y particularmente creo que es muy valioso que podamos desarrollar hoy día jornadas en distintas ciudades a lo largo de Chile. 2 van a ser en Santiago, una en Valparaíso y otra en Concepción, como se señalaba. Y creo que es muy relevante poder descentralizar este tipo de actividades para poder fortalecer los vínculos, porque por más fuertes que sean los vínculos entre Chile y Francia, o por el hecho de que ya contemos con 11 años de instalación de Inria en Chile, es fundamental potenciar los vínculos y mantener el contacto, y creo que el contacto físico juega un rol muy relevante en este sentido para poder revisar lo que hemos ido desarrollando en el tiempo, discutir los desafíos y por supuesto las oportunidades que vienen para poder potenciar la colaboración en el ámbito de la ciencia y las tecnologías digitales, que es el principal foco del centro, ¿no es cierto?, y de nuestra colaboración, pero ojalá abriéndolo también, como ya se está haciendo, a distintos campos de aplicación, incluyendo el cambio climático, la biodiversidad, el ámbito de la salud, las ciencias de la salud, por supuesto la astronomía estando en Chile, y también la agroecología, que son campos de investigación interdisciplinaria muy potentes en los cuales el diálogo científico entre Chile y Francia a partir de la ciencia y las tecnologías digitales creo que es muy relevante. Y también creo que es una instancia para agradecer a Inria Chile por el compromiso que ha demostrado al integrarse en nuestro país desde hace tanto tiempo y acelerar de esta forma la investigación, la innovación y la generación de conocimiento. Un compromiso que como Universidad Católica compartimos y que nos permite a nosotros inspirar y educar a las nuevas generaciones de investigadores, de ingenieros, desde el país hacia el mundo, y poder de esta forma contribuir al desarrollo del ecosistema de investigación y desarrollo junto con la industria, yo creo que muy importante, también incluyendo startups, también incluyendo otros centros de excelencia, ¿no es cierto?, que hoy día participan del ecosistema, como CENIA, como el IMFD, como iHealth, que son plataformas muy relevantes, centros de excelencia financiados por ANIT, para poder ir potenciando el desarrollo científico que hacemos desde Chile junto a Francia para la región de Latinoamérica y aquí es el mundo. Nosotros como Universidad Católica tenemos un vínculo muy relevante con Inria, que ha ido creciendo en el tiempo. Como universidad, junto a Inria Chile e Inria, tenemos un convenio de pasantía. We have an exchange agreement with Inria Chile and Inria, the home institution in France, for an exchange program in the engineering particularly, since 2018. And we have so far have the possibility to have mobility of 27 students, very high standard students at graduate level and mainly master level. And it has been extremely prolific. And it has been renewed last week, no? It has been signed again, the new agreement between our institutions. So in this way, we will be able to expand the possibility of our students. Fostering exchange between students and also fostering the exchange of research programs and the exchange of academics too. Last week I had the pleasure, on Friday we were talking with Cécile. I was able to interact on Friday. We had a meeting in France. That's a bit funny, but yes, it was true. So we had the possibility to meet in France with Jean-Frédéric, with Cécile, with Claire, and with Claude Puech, who was a pioneer of this sort of the install of Inria in Chile. And we're thinking and we're discussing about how we can really continue fostering the exchange of our students at undergrad level and master level, but also how we can move with the exchange of, young researchers, meaning mainly, I would say, like a PhD student and also postdoc at this level, all young academics. I think that's really sort of the core of what we should sort of been emphasizing here. So I believe that if we are able to think about this cooperation and opportunities, we will be able to expand really the impact of what we're doing with this exchange. And I think that the discussion that are going to happen during these days are critical. So I would like to thank the academics from UC that we are going to participate in these sessions. Mainly Pablo Barceló, Denis Parra, Pedro Saá, Paula Aguirre, and Rodrigo Carrasco, who are going to be leading and being sort of main actors in the different discussions that we're going to have. And also I would like deeply thank the French researchers that are with us today, notably Philippe Preux from School Inria, Frédéric Semin from Inox Inria, Antoine Rousseau, et je suis Jairo Rodriguez, Michel Barbier de Epion Inria, Guillaume Fieny de Spirals Inria, as well as other representatives from academia, the other institutions, representing from Inria Chile, and certainly the Office of International Relations from Inria, notably Cécile Vigourou and Claire Saint-Léger, who are always been very instrumental in fostering the relationship. So thank you very much for being here, and all the best for the remaining sessions during this week. Thank you.
Ladies and gentlemen, before we proceed, let's express our sincere gratitude to Pedro Buchon, Vice President of Research at Universidad Católica de Chile, for his warm welcome words. Now, we will hand over the floor to Philippe Vinogradov, Chargé d'Affaires at the Embassy of France in Chile.
Buenos días a todas y a todos. Bonjour. Como representante de Francia entenderán que me rehúso a hablar inglés, entonces va a ser todo en español. Señor Pedro Buchon, o como se dice en buen francés, Pierre Buchon, vicerrector de investigación de la Pontificia Universidad Católica de Chile, señora Nayat Sánchez Pi, directora de Inria Chile, señora Cécile Vigourou, directora de Relaciones Internacionales de Inria, representantes del mundo académico, universitario, científico, representantes de las empresas, amigas y amigos todos. Es para mí un honor y un placer y una alegría participar de la inauguración de las Journées Scientifiques Inria Chile 2023, jornadas que, como se mencionó, tendrán lugar en 3 ciudades de Chile. Agradezco a la Pontificia Universidad Católica de Chile, uno de los actores académicos más relevantes de América Latina, al recibirnos en sus instalaciones. Quisiera también agradecer a la ministra Echeverry por su compromiso para trabajar con las autoridades francesas para fortalecer y renovar la cooperación científica entre nuestros 2 países. Aprovecho la oportunidad para felicitar a todos los equipos de Inria Chile por la organización de este encuentro y por la exitosa movilización de un espectro amplio de instituciones académicas y científicas vinculadas a las tecnologías y las ciencias digitales. Valoro también la participación de las empresas, pymes y startups presentes, hecho que subraya que esta convocatoria ambiciosa va más allá del sector de las ciencias digitales, ahora imprescindible tanto para nuestras sociedades como para nuestras economías. No quiero olvidar de mencionar los numerosos científicos franceses y chilenos, algunos presentes hoy, que desde hace más de 10 años, gracias a la presencia en Santiago de Inria, Chile, se dedican a trabajar juntos para promover la excelencia científica, la innovación digital y tecnológica. En este marco, la presencia y la labor destacable de Inria Chile desde 2012 constituye, sin lugar a dudas, un win-win. Lo siento, usé una palabra inglesa. Un win-win asociación, una asociación beneficiosa para todos, un logro ejemplar y una oportunidad para dar un paso adelante en el campo de la innovación y de las ciencias digitales. Tenemos ahora que consolidar este espacio de colaboración entre Francia y Chile. Las jornadas científicas tienen un objetivo operativo muy útil: reunir los actores de un sector dinámico e innovador y dar visibilidad al trabajo mancomunado de la comunidad científica franco-chilena en ciencias y tecnologías digitales e inteligencia artificial. Estas jornadas se inscriben también en un marco más amplio e incluso, diría, estratégico: reforzar la cooperación bilateral en una nueva prioridad transversal para abrir nuevas oportunidades de colaboración. Como representante de Francia en Chile, permítanme destacar esta asociación ejemplar que permitió, hace un poco más de 10 años, invertir capital humano, financiero y tecnológico en la creación del primer y hasta hoy único centro de investigación de Inria fuera de Francia. Más de 100 proyectos en R&D, en ciencia y tecnología digitales, se implementaron desde 2012. Fomentar un espíritu empresarial, apoyar a la formación de los talentos de mañana gracias a los programas de capacitación y formación en Francia y Chile, son algunos logros importantes de Inria Chile desde su creación. Es una gran satisfacción ver que Inria Chile es ahora un catalizador de innovación tecnológica, de transferencia de conocimiento, colaborando eficazmente con empresas, universidades, instituciones públicas y startups para afrontar los retos de la revolución digital. Como institución pública, tiene un papel fundamental para impulsar con más eficiencia en Chile un ecosistema sólido basado en la inteligencia artificial y la innovación. No puedo olvidar de mencionar la cooperación estrecha que se construyó entre Inria Chile y la Embajada de Francia, permitiendo, por ejemplo, la implementación de proyectos como el Trophée Startup, organizado por Inria Chile, la Embajada de Francia en Chile y Business France desde 2020, programa de apoyo integral para startups chilenas que buscan internacionalizarse para seleccionar startups chilenos que luego se beneficiarán de un programa de formación y aceleración en Chile y Francia. O también quiero mencionar su participación en el Ocean Hackathon Chile con el Institut Français du Chili. Como ya lo dije antes, tenemos ahora el reto de fortalecer y perenizar esta cooperación de excelencia que puede facilitar la afirmación de Chile como referente para el continente sudamericano. Fue recientemente un tema prioritario de las conversaciones entre nuestros jefes de Estado durante la visita del presidente Boric a Francia el pasado mes de julio. Sé que desea trabajar, señora ministra, lo digo de lejos, para dar a esta cooperación las bases institucionales sólidas que merece para reforzar su sustancia, en 2 palabras, para permitir dar un salto cualitativo a nuestra relación bilateral. Este compromiso compartido de hacer de la innovación, de la inteligencia artificial, de las tecnologías de la información y de la comunicación, energías renovables, movilidad, ciudad sostenible, los nuevos ejes de nuestra cooperación es, creo, una garantía y un incentivo para todos los actores institucionales y de terreno para desarrollar proyectos comunes y soluciones digitales en los laboratorios, empresas, universidades y en particular los centros de investigación franco-chilenos existentes en el sector de la inteligencia artificial y de las energías renovables. Les deseo a todas y todos unos trabajos fructíferos en estas Journées Scientifiques y les agradezco mucho su atención. Muchas gracias.
Our sincere appreciation, Mr. Vinogradov, for your continued support and efforts in fostering international collaboration. También lo voy a decir en español. Muchas gracias, señor Vinogradov, por su continuo apoyo y sus esfuerzos para fortalecer las relaciones internacionales y las colaboraciones internacionales. Now it's a pleasure to introduce Jean-Frédéric Gerbeau, Deputy CEO for Science at Inria. He will connect us online, live. Let's welcome Mr. Jean-Frédéric Gerbeau.
Can you hear me? Yes, it's okay? Yeah? Okay, so let me start. Dear representative of the French Embassy, dear representative of the Pontificia Universidad Católica de Chile, dear Pedro, and dear colleagues. I am very pleased to introduce today the Inria Chile Scientific Days. I would have loved to have been with you physically, and I'm sorry it wasn't possible. After 11 years of existence, this is the second time in 2 years that these days have been organized. I see this as a sign of the vitality of Inria Chile's scientific activity. These 11 years of existence and successful activities were made possible by the support of COFO, ANID, and also thanks to our partnerships with Chilean universities. I find fantastic that 4 of them will welcome us during these 4 days. Pontificia Universidad Católica de Chile today, Universidad de Chile, Universidad Federico Santa Maria Valparaíso, and Universidad de Concepción. We are very, very grateful to them. And successful activities that were also made possible. I'm sorry, so I have a message from you. We hear some interference. Well, I'm sorry. Okay, let me see if I can fix the interference.
Now it's perfect.
No, not better. Okay, so I'm afraid I cannot do better on my side. I'm sorry.
Okay, so I'm sorry, but I cannot do better. So it's okay. Okay, I can see your thumb up. Okay, so we'll do like that. I'm very sorry about that. Okay, so successful activities were also made possible thanks to the French Embassy and to the French and Chilean governments that have closely followed the development of Inria Chile. I would like to thank them all for their continued support. For those of you who do not know Inria very well, I would like now to say a few words about our institute. Inria is the French National Research Institute for Digital Science and Technology. Inria's historical motto is scientific excellence and transfer. Our institute is the only one in France only dedicated to digital science and technology, and is unique in that it comes under the dual authority of the Ministry of Research and Higher Education and the Ministry of the Economy. We like to see Inria as a bridge between academia and industry. With more than 4,000 scientists, 220 project teams, most of them being joint with the university, we cover most of the fields of computer science and applied mathematics, AI, programming languages, mathematical modeling, telecommunication network, cloud, and so on and so forth. The diversity of topics is the strength of the Institute, and we consider it essential to preserve it. Nevertheless, in our strategic roadmap, we have selected a few priorities for which we have sought dedicated funding. First, trustworthy artificial intelligence. Second, quantum technology. Third, cybersecurity. And fourth, high-performance computing. And of course, major application sectors such as personalized medicine, precision agriculture, sustainable development and energy, and lifelong learning. Several of these strategic themes are reflected in the projects carried on at Inria Chile. No surprise here. AI, of course, and applications in astronomy, agriculture, environment, and so on and so forth. The interest for Inria to develop some of these topics in Chile is clearly the excellence of the Chilean research. On a personal level, I had the honor of serving on the program committee of the Chilean Millennium Scientific Science Initiative for several years, and have seen a large number of proposals at the highest international level in mathematics and in computer science, which shows an extremely dynamic national community. The recognized scientific excellence of Chilean research was clearly one of the reasons why Inria decided more than 10 years ago to develop this ambitious and unprecedented program to have an office in Chile. This was really an exceptional choice for Inria, as we have very few places in the world with such representation. In the spirit of Inria motto, Inria Chile is now a place where are carried out both excellent research and innovation projects. These scientific days are a good opportunity to showcase some of them. Our ambition is to continue and expand our activities in Chile, in research and innovation, both in conjunction with major Chilean universities and in collaboration with companies established in Chile. This activity will fit in naturally with our vision of Inria as a support organization for French universities. It will also adapt to the evolution of French research institutions into program agencies, as called for by President Macron. We had the honor of discussing these recent developments with Minister Etcheverry during her visit in France last July, and we'll have the opportunity to continue doing so early next year to shape the future of Inria Chile together. To finish, I would like to thank the program committee and the team of Inria Chile for the organization of these 4 days. The choice of a hybrid event, face-to-face and video conference, that travels around 4 different sites make for sure the organization more complicated, but it's an excellent opportunity to promote direct human interaction with a reduced carbon footprint. We all know that it's a difficult equation to solve. So I wish you a very successful itinerant meeting. Thank you very much.
okay? Oh, perfect. So I was saying that it was a tough decision to choose the language we will choose for the speech and for the event in general. We chose the English one, and also because we have researchers that are connected also via streaming line. So I will talk in English, okay? So Mr. Pedro Buchon, Vice President for Research at Universidad Católica de Chile, Monsieur Philippe Vinogradov, Chargé des Affaires Embassy of France in Chile, Monsieur Jean-Frédéric Gerbeau, Deputy CEO for Science and Inria, Madame Cécile Vigouroux, Director for International Relations at Inria, Vice Rectors of Chilean universities, researchers, academic presence, representatives of Chilean and French companies and the industry and the innovation world, colleagues and friends. On behalf of Inria Chile, I'm honored to welcome you to the Inria Chile Scientific Days 2023, a gathering of brilliant minds dedicated to exploring the transformative power of digital sciences and fostering a stronger partnership between France and Chile. This event, co-organized with 4 esteemed Chilean universities, marks a significant milestone in our shared journey of scientific advancement and innovation. We gather today at a pivotal moment in history where digital sciences, and in particular artificial intelligence, are rapidly transforming every aspect of our lives, revolutionizing industries, transforming communication, and shaping the way we understand the world around us. These advancements hold immense potential for progress, but they also present significant challenges that we must address collectively. One of the most pressing challenges lies in ensuring that digital sciences and AI are harnessed for the benefit of whole humanity. We must strive to develop these technologies responsibly and ethically, considering the impact on society, the environment, and the economy. At Inria, we are committed to address those challenges and create a better future for all. Chile, with its vibrant entrepreneurial spirit and commitment to knowledge creation, is well positioned to harness the power of digital sciences, as it has the talent and the vision to become a regional leader in this exciting domain. However, realizing this potential requires a concerted effort from all the stakeholders, including researchers, academics, industry partners, and of course the government. We must foster a collaborative environment, an ecosystem that promotes knowledge sharing, encourages innovation, and bridges the gap between academia and industry. The Inria Chile Scientific Days serve as a proof of our commitment to fostering these connections. This event brings together the leading scientists from Inria and our Chilean colleagues, the university partners that share the latest research breakthroughs, discussing emerging trends and explore potential areas of collaboration. It is worth highlighting and thanking the trust and the commitment of governments, Chilean and French, through their different institutions. In Chile, the Ministry of Sciences, Technology, Innovation, and the National Research and Development Agency, and in France, Inria and its ministries of higher education and research and economy, finance, and industry who support us. I would like to extend my deepest appreciation to the Minister of Science, Technology, Knowledge, Innovation of Chile, Aitken Echeverry, for her words and also for her vision and support for a long-term partnership with Inria in digital sciences. Her leadership has been instrumental in aligning our visions and efforts. I have a special words for the French Embassy in Chile, to its Chargé des Affaires in representation of the ambassador, and to all the embassy services for the great support. This event would not be possible without the collaborative effort of our esteemed partners, universities, the Pontificia Universidad Católica de Chile, the Universidad de Chile, the Universidad Técnica Federico Santa María, and the Universidad de Concepción. I express my sincere appreciation to each institution for their commitment to fostering scientific cooperation with Inria through Inria Chile. My heartfelt gratitude to Pedro Buchon, Vice President for Research at the Universidad Católica de Chile, for hosting the first day of the Scientific Days, for his words and dedication to support the scientific collaboration between Inria and PUC, and also to the Dean of the Faculty of Engineering of this university, Loreto Valenzuela. Also, thank you very much to the Academic Vice President of the Universidad Técnica Federico Santa María, Andrés Fuentes, the Vice President for Research and Innovation of Universidad de Valparaíso, Soledad Torres, the Vice President for Research and Development from Universidad de Concepción, Andrea Rodríguez, and to the Dean of the Faculty of Physical and Mathematical Sciences of Universidad de Chile, Marcela Munizaga. And thanks to all the support teams that work together with us in the organization of this event. Join me in extending my sincere appreciation to the President of Inria, Bruno Sportis, for his support, and also to Jean-Frédéric Gerbeau, Deputy Science at Inria, for his words, and also Claude Puech, the President of the Board of Inria Chile, who would love to be here today and is following us via streaming, and also to Cécile Vigoureau, the Director of International Relations at Inria, who traveled from France to represent the General Direction of Inria. Their presence here is a proof that Inria's commitment to the French and Chilean collaboration through Inria Chile. I would like to extend my heartfelt gratitude to the scientific committee members of the Journées Scientifiques Inria Chile 2023 for their dedication, expertise, and unwavering support in shaping the exceptional program we have before us today. Your contributions have been instrumental in bringing together a diverse range of perspectives and fostering meaningful connections between researchers from Chile and France. Also, my deepest gratitude to each and every researcher who will be attending the heart of these scientific days. Your dedication and expertise is the backbone of this event, and it's your collective knowledge that will drive the discussion and innovation over the next 4 days. Furthermore, I cannot continue without extending my appreciation to all of our colleagues from Inria who have traveled from France to join us in this cross-cultural and multidisciplinary exchange of ideas, and for the ones following us in streaming live. Your presence adds immeasurable value to the diversity of perspectives and expertise gathered here. Also, it is also another proof to the strength and vitality of the Inria French-Chilean network of researchers. A special acknowledgement goes to a wonderful team of professionals at Inria Chile, whose unwavering commitment and tireless efforts have been instrumental in bringing to life everything that will unfold during these 4 days. Your hard work and passion have led to the foundation for a successful and enriching experience for all participants. Thank you, thank you, thank you really very much. I also want to express my sincere gratitude to each and every one of you who are here today, every one of you, and also in the streaming live, as you undoubtedly constitute the most crucial factor in this gathering. Your presence here signifies a shared commitment to advancing the frontiers of knowledge and fostering collaboration between France and Chile in digital sciences. As we embark on these scientific days together, your engagement, discussions, and insights will play a pivotal role in the success of this event. In your hands lies the power to amplify the impact of the scientific advancements we discuss and perfect ideas that will pave the way for future breakthroughs between France and Chile, between the European Union and Latin America. Your dedication to pursue the knowledge is what makes this gathering truly extraordinary. For the last 11 years, Inria Chile has been instrumental in creating a community of researchers who share common interests and goals, and we formalized it last year through the launch of the Inria French-Chilean Network of Researchers to be as a platform where these scientific days are contained to provide us with a remarkable opportunity to deepen this collaboration, explore new horizons, and pave the way for future breakthroughs in digital sciences. Over the next 4 days in Santiago, Valparaíso, and Concepción, we will delve into the forefront of digital sciences, discussing topics ranging from artificial intelligence to mathematical modeling, simulation optimization, Internet of Things. Our shared focus on crucial areas such as climate change, biodiversity, health, astronomy, energy, and our ecology underscores the profound impact of our collective efforts. I encourage each participant to not only engage in the enlightening keynotes and sessions and debates, but also to actively participate in the networking opportunities. The connections we forge during these days have the potential to shape the future of our French-Chilean scientific landscape. May this event inspire us all to collaborate, innovate, and propel the field of digital sciences to new heights between France and Chile. Thank you, and let the Inria Chile 2023 Scientific Days commence.
Director Sanchez P., thank you for your leadership and dedication to fostering vibrant research community. Inria Chile's contribution under your guidance have been remarkable, and we look forward to continued success. Now let's proceed to the scientific session 1.1, Artificial Intelligence, chaired by Pablo Barceló from Universidad Católica de Chile.
Hey, welcome everybody to our first scientific session. And we will start with our first keynote by Antoine Rousseau from Inria Center at Université Côte d'Azur from the Lemon Project team. So Antoine is a senior researcher at Inria, head of the Lemon team in Montpellier. He specializes in geophysical models for the environmental sciences and is particularly interested in the coupling of these models. More recently, he has been focusing on the simulation of urban and coastal flooding at different resolutions with the aim of minimizing the numerical cost of computational models, either at constant accuracy or even by accepting the loss of part of the diagnosis provided by the models. Thanks very much, Antoine, for being here.
Buenos días. So Nayad explained that we had to choose a language. On my side, I cannot choose anyone because if I speak French, maybe half of the audience will not understand, and if I speak Spanish, nobody will understand anything. So, sorry, but indeed it is preferable to speak in English. Okay. Thank you very much for the invitation. Thank you, Pedro Buchon. Thank you to Mr. Vinogradov. Thank you, Jean-Frédéric, and all the colleagues in France. And here, thank you, Nayat and Cecile, for welcoming this event and organizing everything. Really, I want to thank todo el equipo Inria Chile, porque yo sé que está un trabajo muy grande. As Jean-Frédéric said, we all know that it is difficult to organize one conference at one place, but organizing a hybrid one at 4 different places is quite a challenge. So really, it's a great work. Thank you very much. And last but not least, I want to thank Claude Presch, who is probably the guy who invited me in 2016. So he's probably the guy who is the reason why I'm here today. So Claude, je pense que tu dois écouter. Je te salue. Okay. So I'm very happy and very proud to be here in front of you. I'm going to give you a lecture on the work that we've been doing in the team in the past years. And of course, I will also provide some future plans, and in particular with people from PUC. So this is regarding multi-scale modeling for shallow water models. So the first thing is that floods are strong stakes worldwide. So this is a picture I took in 2016 in Santiago. It was a very large flood I think it was in April. I spent a year here. Of course, it's not something very typical to Santiago. We also have very big floods in Montpellier and in south cities in France due to episode Sevenol, the large rains coming from the small mountains that are just north from Montpellier. And as you can imagine, the costs related to these flood-related events are increasing. They are increasing because of the change in the climate and in the change in the intensity of extreme events. So the alea is increasing, but also people are engaging new contracts to insure themselves more and more because the risk is increasing. So because of that, a lot of money is involved now in the evolution of flood-related costs in France and everywhere in the world. So the numbers I have here are just recent, maybe a couple of weeks ago, from the Caisse Centrale de Réassurance in France, and it's based on the IPCC report. So I don't think here in Santiago I have to convince you of the importance of being able to model floods, right? These simulations, they are needed everywhere, and I would say at every time. Of course, you need to have good simulations, good tools before the event to prepare things, to have plans. In France, we have the PPRI, the Plan Pluriannuel de Risque Inondation, so the management of risks for the state. So we need to have precise and trustful simulations. Of course, we need also tools, but that are not the same during the event. Of course, when you have something happening, you need to know where the catastrophe is going to happen, what place should be saved, what hospital, what school, whatever important place should be secured, right? And this requires numerical tools that can be run at a very fast velocity, so it's a real-time simulation, which is very different from the studies we saw just before, right? And finally, after the event, I can show here a small simulation done by a colleague, Fabien Marche, from University of Montpellier in collaboration with BRGM in France. And this is a simulation of what happened on the west coast in France maybe 10 years ago. It was a very, very big event. And finally, it was necessary to understand afterwards what happened. And the insurance companies were very kind to obtain some simulations to really understand where the risk was, etc. So it's also important to have tools that can do that kind of thing. So let me give you a few words on the equations, and I promise it will not be too technical on that part. I will go into more details at the end, but for the beginning, I tried to do something that everyone can understand. And so my favorite equations is the Navier-Stokes equation. So for those of you who don't know it, it's a system of several equations because we live in a 3D world. So we have actually 4 equations in the Navier-Stokes system, 3 for the 3 dimensions and 1 for the incompressibility. So this equation, which is the simplest one here, just says that if you push water in this direction it will go in this direction or in this direction. You cannot compress it. So if you move some velocity in some direction, there will be some compensation in the other ones. That's very simple. Everybody can understand what incompressibility means. Actually, it's not completely true. It's almost incompressible, but in every model, we have some approximations, and this is a very sharp and good approximation for the water. And the 3 equations that come for the description of the evolution of the velocity come from the Newton law. And so we have the acceleration here with the derivative of the velocity. We have the density, rho, we have nonlinear terms that I wrote in red because there are those who create a lot of difficulties for people that work on these equations. You have the pressure force, you have the gravity, of course, gravity plays a role. Viscosity terms, if you consider viscous fluids, which I will not do today, and of course external forces like wind, rain, sun, whatever external force that comes to your system. These equations are too complicated, so if you expand them in all the directions, and again, we don't need to understand what's going on in every single equation here, you may simplify things. So the first simplification, I already mentioned it, is I consider an inviscid fluid, okay? And I even simplify more, and I consider a hydrostatic approximation. This is due to the fact that I consider fluids that are very large in comparison to their depth. Imagine, for example, the Atlantic Ocean, which is between our countries. It's several thousands of kilometers wide, while the depth is hundreds, maybe 1,000 meter maximum, or a couple of thousand meters. So the ratio between the vertical and the horizontal scales is very, very, very small. And because of that, you are allowed to neglect some terms in the equations. That's exactly what we do here, okay? So the vertical direction is a very specific direction in these fluid models, and I am authorized, because physicists say so, to simplify a little bit the model, okay? And it changes life, really, because it changes the computational difficulty of the model, okay? Not only the equations are simpler, but the time to solve them for the computer is much, much lower, okay? And actually, Jean-Frédéric Gerbeau, who I don't know if he's still online, but he's a scientist who contributed a lot in the understanding of these equations, the shallow water equations, with some papers with Benoît Pertam, sorry. And the idea of Adhémar Barré de Saint-Venant, so it was a long time ago, but a lot of work has been done in recent years to deeply understand these equations. They transform this 3D physics into 2D equations. That's what I try to explain with this aspect ratio. And because of this, you can simulate a real 3D event with 2D equations. And if you think of the computational time that is required, of course it's way better because you can rely on a single 2D matrices instead of having 3D, which is really easier. And so for the shallow water equations, which are the equations I will consider during all this talk, we have only 3 equations. So the first one is the mass equation, the same, well, let's say it's very similar to the incompressibility. It says that the evolution of H, the water levels, depends on the divergence of what comes on the sides. So it's again another way to say that we have an inviscid fluid. Conservation of mass, very important. And the rest of it is the conservation of momentum equation. And again, I don't want to go into details today. If you have questions, I can answer, but it is not the core of this talk. And again, this comes from the Newton law and from the simplifications we made just before. Okay? So again, 2D model for 3D physics. Now, let me come to 3D, 3 recent contributions, or maybe 2 recent contributions we had. Pablo, if you can just tell me 5 minutes before, so that I'm sure I will not last too long. So yeah, I will concentrate on two recent distributions, maybe 3 at the end. So the first one is the porosity models for shallow water flows. So this is a typical example of a flood simulation in Sacramento in the US. So this has been done by Vincent Guinaud, a colleague of mine in the team Lemon, and Brett Sanders from University California, Irvine, UCI in California. And you see here a flood map. So this is actually a part of the town of Sacramento. In white here you can see buildings, okay? And on the left here you have a channel with a dike the event that we are going to study is a failure. So there is a large amount of water that comes from the left to the right into the city. And what you see here in color is the map of the water height. Okay, so in red it means that the water is at I think it's 8 meters, and the very green is 0. Okay, below 0 and 8 meters. And the river, the channel, is just above the city, so it flows down into the city. Okay. So the only thing is here you can see a wave that just came into the city and that is hitting the first buildings, right? It's the red part that you can see. And a very important thing here, which is in white and black, but still it's very important, is the mesh. So as probably most of you know, we need a mesh to make the computer understand the continuous equations we had just before, okay? We start from continuous equations, and we do some kind of discretization, and we cut our domain into lots of cells in which the water level, the velocity, the pressure, whatever quantity you want to compute is assumed to be constant or simple, okay? And again, the more cells you have in your mesh, the sharper and the more accurate your simulation is. But the more cells you have in your mesh, the more time it takes to make the simulation, okay? And in particular, if you're interested in the second step I talked about just before, the step in the crisis management, when you need to have real-time operations, these can be very, very, very slow. Well, not so slow, but too slow to realize real-time simulations. So it is very important to have considerations on this mesh. This is a picture of Montpellier, the city of Montpellier, and here you have a numerical simulation of a flood inside the city. And here you can see a red square, which is zoomed here, okay? So you have a roundabout and a couple of streets going on. And at this scale of 10 meters, you can see the number of mesh cells that we need to have a precise simulation of the flood in the city. The mesh size here is around 10 centimeters to be correct, okay? So if you imagine that you have a large city, maybe 1 kilometer over 1 kilometer, or 10 kilometers over 10 kilometers, if we talk about Santiago, that's millions of grid points, okay? And of course, as I said before, the more grid points you have, the more difficult it is to have a reasonable time computation. So the idea would be, what if I solve the same equations or on coarser meshes? So this is my original mesh on Sacramento, and now I want, for some reason, because I have a small computer or because I want to go fast and everything, I have this coarse mesh. What if I do the simulation on that? I don't show you the result because it's a catastrophe. Of course, it's very, it's not good enough to be shown. So we need, and this is the objective of the porosity models, we need to recover in the models, I mean in the equations, the physics or the information that we lost with this coarsening of the mesh, okay? So I have a couple of very important things, my equations, my mesh. And all of this, I give it to the computer and I do my simulation. Here, I just want to modify the equilibrium, the budget between the effort made by the two. I reduce the complexity of the mesh, so I want to improve the quality of the model to compensate, not completely, but at least a little bit, the loss of information. So we define a porosity. Let us call it phi. So these are the buildings in the street, okay? And this is the fine grid, okay. And now I have my coarse grid with the same buildings, but as you can see, some buildings are shared by two cells, some buildings are inside one single cell. Well, there's no coherence between the buildings and the mesh. And then, on this mesh that is very coarse, I define phi, okay, a value, which says the amount of space that is free for the water to flow inside the cell. So, for example, if I take this one, I have maybe 30% of the cell that is taken by the building, and 70% of the cell that is free for the water to flow inside, okay? And I call it phi, and I say this is phi equals 0.7, okay? And I do the same for all the cells in my coarse mesh. So again, I define a scalar map, phi, on the coarse mesh. And now, I can change my equations. And again, I will not go into the details, but the idea is to change H, which tells the amount of water that is available in the cell, into phi H. So in the previous equations I showed a couple of slides before, there was no phi here. There was derivative of H divided by dt. And here I have derivative of phi H. And everywhere I have an H, I change it with a phi H. And because of the nonlinear terms here, this had some new terms in the equation which depends on the gradient of phi, so the variations of the porosity in the map. Of course, if I have a porosity equals to 1 everywhere, I recover exactly the former shallow water equations, because having a mesh with a 1 porosity means that every cell is fully available for the flow to flow inside, yes? But here, again, because of this, we have some cells with porosity 1, and we have some cells with porosity less than 1, between 0 and 1. Okay, and now if I go back to Sacramento, I can define my new phi on the coarse mesh. So, for example, this mesh here, this mesh cell, is approximately in this region. There is no building. So the porosity here will be 1. The cell is completely free for the water. But if I take this one, it should be around here. So there is some part of a building inside the cell. And finally, I end up with a porosity of 0.7. And I can have 0.5, 0.2, etc. So I build my whole porosity map. And at the end, this is what I get. So this is the reference solution computed with a very dense mesh with shallow water equations. And this is another simulation made on a coarse mesh, but in which porosity has been implemented. And as you can see, of course, it is not as good as it is on the left, but it is not so bad. And in particular, we can see the structure of the wave hitting the buildings, even if the buildings do not appear anymore in the mesh because they are swallowed by the porosity model, right? Okay? Of course, as I said, this is a little bit less accurate, but it is hundreds or thousands of times faster to run this simulation than this one. So you can imagine that in real-time crisis management, it's important to have at least some simulations before the end of the event. It's like meteorology. If you want to know the weather it's going to be tomorrow, and if your computer takes 3 days to compute the simulation, it's useless, right? It's the same here. So we can imagine that this can be run, and why not? If we see that there is a risk on this place, maybe we can zoom inside and come back to a sharper mesh, but I will talk about that later. A recent application in Santiago. Pedro Buchon mentioned the internship program between Inria and PUC, and I have to say it has been very successful to our team because we welcome Sebastian Nash, who is somewhere here in the room. He came to Montpellier, and he's now starting a PhD program here in PUC with Professor Christian Escoriaza, who is currently in Stanford, but we are sharing a programme Équipe Associée that just started. And that's actually one of the reasons why I'm here. And I'm very proud of these results made with Sebastian, because these simulations are made on a real case in La Reina, in Santiago. And on the top and left part, you have the reference simulation, the one that is simulated with the regular shallow water model with no porosity. And if you go from left to right and from the bottom from the top to the bottom, you have more and more coarse resolutions, coarser and coarser resolutions. So the last one is not so good, as you can see. In blue, you have the flooded area, and in white, you have the not flooded, okay? So the last one is not so good. The 32 meters couldn't be improved, but the other ones from in particular for 4 and 8 meters, they are very, very good. And again, here, you scale with a resolution of 4 meters instead of 1. So just passing from the first one to the second one, you divide by 16, because it's a 2D simulation, you divide by 16 the number of mesh cells. So it's really something that goes way faster in this situation, not to talk about 8 meters or 16 meters. So again, it is a very good tool to do some fast simulation of floods in real-time circumstances. And thank you, Sebastian, for these very nice simulations. Now, I switch to a second topic regarding large time steps. So I talked about the space thing, okay? And now I'm going to talk about time. So it is going to be a little more technical. How much time do I have? 20? 20, okay. So I will take time, and I'm sorry for those of you who will not follow until the end of the talk, but I will try to make it understandable. And the idea is to improve the computational cost of the systems with the time simulation. Okay, these are the questions that were asked from our colleagues in Tour du Valat, a foundation for humedales in the south of France, and lakes, and the Camargue region, which is very nice and very protected area, an area where you will be more than welcome to come, very close to Montpellier. And another question made by CEREG, a design study engineering group in the south of France that makes lots of studies for cities or things like that. They have meshes, again, where you can see that you have very large heterogeneities, okay? So here, for example, you have a channel, so you have a very fine mesh in some region, and in the middle of the lake, there is almost nothing. Here you have a river, which is meshed, with two bridges, and with 4 piers that sustain the bridge. And again, you have you need to mesh a little more around the piers to understand exactly how the water is flowing around it. And the issue here is that we have heterogeneity in the mesh, which, and I will explain why a little bit later, which makes difficulties for the time step to be chosen. Why? Because talking with hands, when you do some numerical simulations of floods or that kind of thing, you need to have a time step that is related to your space step. I mean, the information should not cross the whole mesh too fast. So if you have a small mesh size, you need to have a small time size. Otherwise, other than that, your scheme will not be what we call convergent. In particular, you will have some oscillations. Cannot be used for the simulation. Okay. The technical word is unstable. Okay. And we don't want to have instabilities, so we need the time step to be small enough. And this is in explicit time schemes. I don't want to go into too much details, but again, if you have questions, I will be more than happy to answer. So the framework is the following. Imagine that you have a wave propagating at some speed lambda. Lambda is a positive number, and you have a wave, an information, propagating at some velocity. So this is the type of equation that you have, and this is very specific to the shallow water model, okay? But it's more general, let's say. And as I said, for the stability reason, you need to have delta t over delta x times the velocity lambda should be smaller than 1. Again, this says that the information does not cross your mesh too fast in your grid, okay? If you're simulating something that is going at 5 meters per second, if you have a 5 meter large mesh, you need a 1 second time step to compute your system correctly, okay? So for stability reasons, we call it the CFL number, should be smaller than 1. And for accuracy, we need it to be not too small. It means that if I use very, very small time steps, not only I will have a lot of computations to do if I want to go to 1 second, 2 seconds, 1 hour, 2 hours, etc. So not only it will be more complicated, but it will be more diffusive. It means that it will not be as precise as it could be with a good time step. So the time step, ideally, would verify that nu equals 1 or nu is just under 1, okay? For stability and accuracy. Unfortunately, when you have this kind of mesh, you see that you have very different delta x here and delta x here, okay? So assume that you have a comparable lambda, that the velocity is approximately the same in the whole domain, which is reasonable. Then your constraints on the delta t here will be much smaller than the one here, okay? And in total, you have only one mesh size. I mean, when you do the computations, you have your initial condition, and then you compute everything at time delta t, and then everything at time 2 delta t, etc., etc., okay? But you cannot have, at least not easily, have a delta t in some place, another one in another place, etc. So here, if I want to keep the same delta t for the whole domain, I have to take the one that is the most reducing the CFL, because I want this condition to be true everywhere in the mesh. So the places where I have very small delta x, for example here, I need to have very small delta t. And this is an issue, okay? And this is what the colleagues from the companies I mentioned before said, okay, we have these kinds of mesh, and we need to have ideas to have a delta t which would be more comparable to the mesh size inside the lake rather than in the very sharp places. So, yeah, this one is not really useful. So yeah, so a typical example with a numerical simulation of shallow water equations with a 1D dam break. You take a almost regular mesh. I mean, you consider this in X being separated with lots of meshes, and you have of cell meshes, sorry, and here at the left and at the right you have two very tiny cells that will of course be an issue for the system. And so if you consider the simulation, the reference simulation with a regular Godunov scheme with a CFL equals to 1 and traditional simulations, then you have this obtained with a computational time of 0.44 seconds. Okay, this is our reference. And now, if I consider the same simulation with these two cells that we just added in the system, you can see them with the vertical lines here, okay? They are just two simple places where I refine the mesh because I want to see something. I have a pier, I have a canal, I have something I want to see in this place, so I need to refine. But then, if I consider traditional delta t and things like that, with a classical Godunov scheme, okay, I have a not so bad simulation with some diffusion at some places, but in particular, I have a lot of time to work for the computer, 43 seconds in this 1D case. So this is the issue. So our approach, and this is going to be a little technical, but I will be short on that. Okay, traditionally you have fluxes to approximate in the equations, and the first thing you do is to linearize with respect to u, and you transform your time integral into a space interval. Okay, and this is with the same idea I talked about a little bit before. If you have a velocity of 5 meters per second, you transform a problem of 5 meters in a problem in 1 second, okay? You just change variables, actually. And you rely on the propagation of your wave. And in the naive approach, you don't know for a given delta t which is the length of the wave, because it's nonlinear. So in the case where it's 5 meters everywhere, 5 meters per second, it's very simple. But in the case where you have nonlinear systems, you cannot guess. So you can use some d, capital D, which would be an approximation of the real d that you want to have, but doesn't give good results, as you can see here. So this first idea was not good. And in particular, it's not good because the guess we gave for the d is obviously not good in comparison to the real one, which cannot be computed for once for all, because it changes with time, with space, etc. So we have an issue here. And the cure that we propose is to give more power, give more weight to the cells that are located close to the cell we are computing the flux. Again, I don't want to go into too much details, but for those of you who are familiar with finite volumes, instead of looking at, in your classical Godunov scheme, the left and right values in the cells that separate the interface you're watching, you just do a convolution on a certain region on the left and on a certain region on the right, which allow you to get some information on the left and on the right, but which takes more than one cell. And doing this, you have, and this is a very nice technical result, we have a theorem that shows that you have stability. And so the idea I tried to mention here was just a way to switch from one delta X to a bigger one. And doing this, thanks to this convolution kernel, you change the CFL maximum value. And that allows you to take much larger time steps. And this is what we did. And finally, this is a simulation with, again, the reference here, 0.44 seconds. The reference with a modified mesh, which is not good in time. And this one with our new method, with the large time step or large CFL system, where we recover something comparable, even better, 0.28 seconds. And again, we have this particular mesh that, again, I insist, the choice of adding these two cells to make the problem more difficult comes from the engineering companies, because they need to have some heterogeneities in the mesh. Otherwise, I would take, as a mathematician, I would take a squared box of size 1 with regular meshes everywhere, right? But this is not real life. So this is what we've been doing for them. And okay, I can skip the other simulations, but maybe just one in 2D that we recently made. So again, this is the standard Godunov scheme. So this is a river, okay, with two bridges, one bridge here and one bridge here. I didn't plot the meshes, but as you can imagine, the mesh is very fine around the piers and is much larger in the rest of the river, okay? And on the left, you have the standard Godunov scheme with mesh cells going from 5 centimeters to 5 meters. And here, you have exactly the same mesh, but we use the new scheme, the new large CFL scheme, with a typical size of the convolution kernel of 1 meter, which is a good middle point between 5 centimeters and 5 meters. And we have exactly the same simulation. Actually, it's very difficult to make the difference between the two. And the time computation has been divided by 2. Okay. So again, this was, okay, thank you, I will conclude. This was a way to introduce some new features in the numerical schemes to spare some time for the computation. Just a word on software, because it's very important, and we rely on this software in the team. Without this software, we wouldn't do all these studies. So the software is called SW2D Lemon. It has been developed for many years now. The main contributors are here: Carole Delaine, Vincent Guinaud, and Pascal Finoguio. Vincent is actually the head of the project since maybe 15 years ago. He wrote the first papers on the porosity models, for example. And SW2D is a unique, almost open source. I put brackets here because it's going to be open source in a couple of weeks. But if you're interested, you can just contact me. I will provide you with the code. So, okay, lots of software developments, more and more users. Actually, we're very proud to have 4 private partners and 1 engineering school that teaches shallow water dynamics without software in Polytech. And these partners, in particular CEREG and Aegis, they use the software to do some real simulations of risk management for cities like Montpellier, for example. So, I mean, several tens of design studies are made every year in Montpellier, relying on the software. We have some competitors, like Telemac, for those of you who know, in France, or ECRAS in the US. But this one is the only one to include the porosity features I mentioned in the beginning. Actually, there is one that is coming out now in PUC, because Sebastian is running the porosity models in the model of PUC. So we're very glad to have to share this knowledge with colleagues in Chile. Okay, and now just a word on conclusions and perspectives. So I try to mention 2 new shallow water features that we've been improving in the team in the past years. So again, porosity models that allow to reduce the complexity and of course a little bit the accuracy but that provides very, very good, very interesting simulations. Of course, it needs a little bit more engineering time because you need to build the porosity map. Okay, so it takes some time, but it once every mesh, so it's okay. I mean, in the design study company, they do it for once, and after that, they can use the model. We need to work more about confidence. I mean, what confidence can we give to that? That's a big issue. And the second topic was on the large CFL techniques, so with the larger time steps. So it's more efficient in many cases, but again, it needs to choose correctly this parameter D, that is the size of the convolution kernel. And this again needs a little bit of expertise, and for the engineers it's not always very simple because they need to understand, and they don't want to take parameters randomly, so it needs a little bit more engineering. And I want to finish with the current projects. So we include now new features in a porosity model with Sébastien, Christian, and Pascal in the framework of the Équipe Associée float that I mentioned at the beginning of the talk. And in particular, the objective is to include log transport, okay, en bâcle en français, to simulate what is going on when rivers carry lots of things, sand, wood, cars sometimes, in flood events. And another project, which is also with some cool people here, is a project of multi-scale flood modeling. So now that we have, if you follow the beginning of my talk, now that we have precise simulation on very fine meshes, and now that we have low-tech, let's say, coarse simulation, but that can go very fast, the idea with Nayat and Luis in particular is to use some machine learning techniques to do the refinement automatically. So that's a project that we're starting, and that Katja, who is here also, will be leading during the 2 coming years. And with that, I conclude. Thank you very much. Okay, so the question is, I repeat it so that everyone can understand, but tell me if I'm wrong. The question is the mesh done in the software or is it external to it? That's correct? Okay. No, we don't do the mesh in the software. The mesh is an input of the software. Okay, and in particular both meshes. If we talk about the porosity models, both meshes should come from outside, and the porosity map also. So we are working right now on computing automatically porosity stuff, etc. from one mesh. But this requires some time, and it's actually not really a research topic. It's more engineer task, and we're not very good at programming everything and all of this. But you made a good point. The meshes are external to the software. So you come with any mesh you have, any format, anything. We can include it in the simulations. But SW2D does not make the software for you, the mesh for you.
Hi. More a curiosity than like a specific detail is like in these shallow water models, what happens to convection, to convective motion, if that's an issue for.
The approximation of the shallow water model is that you don't have. I went a little fast when I made the simplifications, and again, Jean-Frédéric is an expert of that. But you assume that your velocity U and V are constant in the vertical column. Okay, so it really means that you have a 2D phenomena. I mean, it's constant in the vertical. actually, you can use some multi-layer shallow water models. So it's 2.5D actually. It's between 2D and 3D. You just summarize things with several 2D models that you use one with each other with interactions. And in that case, you could do some convection and something like that. But with a classical 2D shallow water model, it's not included. And I mean, it is part of the approximation that you do at the beginning. You assume that nothing is going on in the vertical, approximately, apart the hydrostatic approximation, so the equilibrium between pressure and water and gravity. Yeah.
Any more questions?
Hang on.
So the software you said that you're going to make open source, is it mostly Python or which language?
It's a C++ code, and you have external routines in Python, etc. But the very core of the code is in C++.
Okay, because for the machine learning part, I would say that Python.
Yes, you're right. So for the machine, that's a point that we're going to talk about. But actually, what we need to do for the machine learning part is to store a big data set that can come out of the code, and then manage it with a PyTorch or whatever Python system for the AI part. But you're right. We cannot rely on the C++ code as itself for the machine learning part. Thank you. Yeah.
Well, coffee break is waiting for us outside, so let's thank the speaker.
Thank you.
Thank you.
Yes, please, let's come back in 20 minutes so we can continue with the program. Thank you very much.
Well, welcome to the second session, second scientific session. Our first speaker is Professor Denis Parra from Universidad Católica de Chile, CENIA, iHealth, and IMFD. And he'll be talking about deep learning for radiological report generation.
Bonjour. The only thing I know in English, in French. But okay, so today I would like to talk about this topic that goes about artificial intelligence, language models, vision models, and multimodality, all in the crossroads with medicine. So I hope you enjoy the talk. First, I'd like to acknowledge many people who are collaborating in this research: Cecilia Besa, Álvaro Soto, José Cañete, René Vidal, and several also PhD and master students from PUC and also from University of Chile. Just a few words about two of the institutes more involved with this research. The first one is the iHealth, the Millennium Institute in Intelligent Healthcare Engineering. Here there is a group of researchers in different disciplines from computer science, electrical engineering, and medicine and public health, all working especially towards medical imaging and improving it with the help of artificial intelligence. And also, I'd like to mention the CENIA, the National Center for Research in Artificial Intelligence from Chile, where the directors are Álvaro Soto and Marcela Peña. Also, Pablo Barceló is a principal researcher here. So all the work that I'm presenting here is in collaboration between these institutions. And in particular in this SENIA, I'm working in the line of deep learning for vision and language. So I would like to show you the details about this applied in medicine. Okay, let's go about these different topics I'll present today. So first one, as a few words of motivation. A few years ago, this book by the medical doctor Eric Topol was released, and he mentioned that by 2016 there were only in the US 800 million medical scans per year, accounting for about 60 billion images. So expecting radiologists to check each one of these to write a report would be very unfeasible. And using artificial intelligence for helping radiologists and also specialists with reporting, and then the hospitals also dealing with this large and growing demand could be like a big potential of improvement. There is another very important aspect that he mentions in his book, and is the time that physicians spend with patients. By 1975, a physician would spend 60 minutes with a new patient or 30 minutes with a returning patient. And by 2019, those times would be reduced by 12 minutes and 7 minutes respectively. The situation is not that different from Chile. So AI does not mean really replacing physicians. It's actually helping them spend more time with patients and not too much on the machines or with systems that sometimes are not very effective or efficient. Having said that, just for the matter of having an idea of how the workflow goes, one sees a patient usually, and for me, for instance, that I'm not a physician, I would think that all goes through one single physician doing the imaging, the exams, and everything. But in fact, what we have is a primary doctor, which is a general practitioner or a specialist, and she or he asks for specific exams. And then the radiologist conducts these imaging exams that could be X-rays, could be magnetic resonance, scanners, PET, and then it reports. She or he reports to the primary doctor, who finally reports to the patient, indicating the decision and also the diagnosis and prognosis, what is going to happen next. And one particular task we have been working on in the last 2 or 3 years is the generation of radiological report for chest X-rays, mainly because we have data about this. Now lately we are little by little having data on different parts of the body, also different kinds of images, but the biggest data sets are about this part of the body. And just want to mention that you can have one or more images with certain manual or automatically obtained labels. And also the report is not just a single piece of free text. Usually you have different sections. For instance, you have a section called comparison and indication that provide you background information of the patient. And you also have findings, which in Spanish would be hallazgos. That is just a set of observations of what the radiologist sees on these images. And finally, you have the impression, which is the diagnostic. This changes sometimes depending on the part of the body. For instance, in breast or in I don't know, like a broken bone or something can change, but more or less this is the structure that you see. So then, when you talk about generating the report based on the images, you really need to make sure what are you generating. You're generating the findings, the impression, and we are going to see certain variation of this task. So in our group, we started working first by developing a very detailed survey on the different techniques, data sets, and the modules that a system like this have. Then we developed our first methods for generating reports using templates for text. And now, of course, we are also working with the automatic text generation with transformer models, and we are going to explain a bit more details on this. So first, for you to have an idea, the different components that we have in a system that inputs images and then generate text, first is that you do not only input image, you can have one or several images, but you can also have this patient background. That can be information from the patient or from the situation that brings the patient into having this medical image exam. Then you have the model itself that, of course, is going to have a visual component that processes the image or images, and also can process certain domain knowledge, like medical specialist knowledge that can provide better grounding for the language component, which is, in the end, the responsible of producing the free text report. But apart from the free text report, maybe sometimes you want, for the physician, to have a bit more explanation, and you might provide, let's say, a text heat map showing where the model is paying attention to in the text, or in the image itself, if looking at the lungs, or the heart, or the pleura. You can also produce explanations with different models, like a counterfactual image explanation, and you can also provide additional labels or classification. So in these models, the common backbone is deep learning, right? And deep learning, probably everyone here has heard about that. The base technology used here are the neural networks, and neural networks are known from the 50s. But the models started improving a lot from 2011, from this ImageNet challenge, where the error rates for a specific task like this, which is object detection, by 2015, the models had smaller error rates than the humans in detecting objects in specific pictures. And one of the main aspects of this deep learning revolution is that it changed the way that we were doing artificial intelligence in the past. In the past, we really had to be manually creating features in order to give them to models for training and for solving certain tasks. But then at a certain point, we had deep learning that allow us to remove the manual feature engineering and just automate it with deep learning. So with deep learning, we have a complete end-to-end backbone from input data, text, images, videos, and then solving the task without the need for learning the features. So there is a positive side on this, that we can run a lot of faster models. We can do a pipeline that works more efficiently. But the negative outcome is that sometimes we don't know what the network is learning. And that can be a problem, especially in critical domains like in medicine, where the doctor wants to know what the model is learning in order to diagnose certain illness. So this deep learning solution in general has these three components. We have, let's say, one or more images, and then we have a visual encoder, which is indeed a deep neural network. Usually there are two main architectures, the CNN, which are the convolutional neural networks, and also the transformer model, which started most on text, but then it has also moved to representing visual or audio or video type of inputs. Then we learn certain visual features here, and we provide these learned visual features to a text model, which we are going to call the text decoder. And the text decoder has the task of really producing the text that we see in, let's say, ChatGPT. And this has changed a bit in the last 5 years, since the transformer was released in 2017. Initially, we have mostly CNNs producing the representation for images, and recurrent neural networks like LSTMs for generating the text. But now we have also visual transformers for the visual backbone, and mostly transformers have completely replaced sequential models in the text generation side. So let's talk just a bit about the vision models and works that we have done in our institutes in the past. In 2021, the team of Catholic University of Chile participated in this international medical caption prediction task, and we won that task. And at that time, this is an applied challenge where we use a ResNet backbone and some adaptations in the laws and in other parts of the hyperparameters in order to produce the correct captions for input images. And then, using a variation of these methods, we use a DenseNet 121 convolutional neural network, and we work closely with the radiologists here at the Catholic University in Chile in order to produce certain templates of anomalies, and for each anomaly, writing a text report. So then the report would be constructed mostly by using an automatic image decoder classification, and then a template for generating the test. And the performance of that model actually is quite good, but it's not very flexible in terms that if you identify new anomalies, then you need to produce manually another template, and it's not like a potentially fine-tuned or trainable transformer model. But here, I want to mention also the fact that visual transformers are taking on the field too, and they have a very particular way of processing the data. Basically, they take the image and they turn it into a sequence of tokens, just like it would be a text. So for instance, you have here an example of a potential image of a brain, and then you make a grid out of that, and each of the different cells of this grid is an input in this initial linear projection. Then you need to add like the positional encoding, and then you can input it into the transformer encoder. And these are the traditional blocks of the transformer, where you have the components of self-attention, multi-head attention, and also some other aspect like residual connections and normalization after certain layers. And with that, then you can have a head that in this case does the classification of tumor or normal in this particular example. Now in this very recent survey on transformer in medical imaging, you see several tasks possible, like segmentation, which is very popular in medical imaging, classification, detection, etc., and also clinical report generation. And in the case of clinical report generation, the state-of-the-art model is this M2 trans, which actually combines several techniques like reinforcement learning, transformers, and also natural language inference. But when we look deeply at the results in the supplementary materials and we check different anomalies, we found out that their model actually is even worse than the template-based model that we created 2 years ago. So this is a problem not solved yet. And in the discussion, I'm going to provide some ideas about that. But the thing is that regarding vision models, despite visual transformer are outperforming CNNs in certain tasks, there is not such a big gap, and you can tune your convolutional neural network to still perform at the level of visual transformer, which is a completely different thing in text, of course, but just to have you in mind. So when we talk about language models, we are hearing probably from the end of the last year the word language models, and not many people know what a language model is, but it's just a model that assigns probabilities to words or to sequences of words. And so formally, it is a probability distribution over sentences in a language. So in this example, probably the training data set is not too much about medical information, and that's why the sentence lengths are inflated, has way smaller probability than ChatGPT writes a novel, which is 0.1, larger probability. Now, that's what a language model is, but when we talk about language models in general, we are talking about neural language models, which means that Most current language models are neural language models, which is that a neural network is used to estimate the parameters of the conditional probability distribution. So I start with a prompt, which is what we usually write in the ChatGPT, and then when the model has to predict the next word, and then input it again in the prompt, and then iteratively generating the next word, then it's a neural network, the one doing this work of estimating the parameters. And unlike computer vision, where there's still a gap, no big gap between convolutional neural networks and visual transformers, in NLP, the transformers has completely outperformed the previous recurrent neural networks and LSTM by big gap. So it's by far the state of the art. And if you want to know more about this in detail, I really advise you to read this speech and language processing book by Jurafsky and Martin, and which is online, so it's a very, very good resource. And one thing to at least that is good to know in order to understand the different architectures is that I mentioned before that for text generation, we have the decoder, which is the one in green here, but there are other architectures too. We have the encoder architecture, which is the BERT, for instance, is an example, it's a very popular encoder architecture. So we reduce the dimensionality. We input text, let's say a sentence, and then we end up with an embedding or vector with fewer dimensions, but then we can add a head to a classifier. In the case of a decoder, we are increasing the dimensionality, and that's usually used to generate text. And in other cases, we want to, let's say, translate from one language to another. That's usually an architecture for encoder-decoder, like BART and T5. So in terms of, 2 minutes? Okay. In terms of tasks that in radiology, which are related only to text, one which is very popular is generating the impression, which is the final short diagnostic from the finding, which are the observations that the radiology writes when she's observing the images, right? And there was a challenge in the ACL conference this year called BioNLP, which was about this, and one nice addition of the challenge in this year is that they try with different parts of the body and also with different images, like CT scans, magnetic resonance. That was very useful. And here we are starting to see the same trend that you probably have observed of all the family of language models. We have been hearing of GPT, but also the open source version like Llama V2, and all the different derivatives by fine-tuning them, like Guanaco, Gorilla, etc. And in this case, they use a model called Bloom that was also an open source version of a previous model, and they fine-tune it in order to be able to summarize from findings to impression. And the team from Siemens doing this did very well, and actually they won that particular challenge. So just to end, we are using here two modalities, images and text. So then how we use text and visual data to improve either both representation. And here is where multimodality shows up. So this is also a very hot topic right now, where rather than learning only text representation or vision, we try to learn them both together. And transformers, for instance, a very good architecture in order to put together different types of modalities, like video, text, or audio, put them all together and learn representation that then can make us move from one space to another. So if we consider only two modalities, like image and text, we can do retrieval, for instance, from image, retrieve text, or captioning, or generation, or visual question answering, so there are several possibilities. These models are not that new. Actually, from 2013, we saw that Soher already was experimenting with trying to represent in the same vector space both images and text. And the first multimodal models were not using transformer. They were using just typical CNN backbone with LSTM to generate the text, but they were not working as well as the current models. And right now we are seeing the same adaptation of those models now with BERT, for instance, where you can input text, but now you are using also the visual representation in the same model, or models that are a bit more shallow in the sense that they have one particular model to represent text, another for representing image, but then you do a contrastive learning loss in order to then trying to approximate the visual representation to text and text to image. This is being used a lot, CLIP. You're going to see a lot of applications on this. And there are many models also. I'm showing here on these slides the potential model here to work on this. And based on this idea, the last year in MedNeurips, we presented this two-stage conditional chest X-ray report generation, where we had a visual encoder, also labels that gave us information about different anomalies. We put this backbone into predicting several tags like label classification, gender classification, the view, and then we put also a transformer decoder. And with this, we obtained really, really good results. There is still room for improvement, but they were really good. And how much time do I have? No time, okay. So I wanted to mention 3 things for discussion. First thing is the need to generate bigger and public data sets for medicine. Okay, we have a lot for public data, general data, but not for medicine. Also, the need to care for making this progress not only for the Western society, like white. We also need to make sure that these models perform well on different populations. And also, there is still a problem in long-tail classification. There are certain illnesses and anomalies with very few cases, and we are still not learning well from this small amount of examples. And yeah, that's it. Thank you.
Time for questions. No questions? Over there.
So, hi. I wanted to ask if there anything to say about the specific challenges of training the model, specifically for the Spanish language and maybe for Chilean language if we wanted to apply it for here, for our country?
Yeah, thank you for that question. There is one data set called PATCHEST that has X-rays, and they were collected by 2 Spanish hospitals. But when they provided the report, they really cleaned it too much. So they only provided keywords, not free text. So, but that's the closest that you can have to using this type of data in Spanish. And right now we are developing a data set with the help of the Catholic University. And we hope we can release it within 1 year or so, because we have to be very careful in creating this data. And also we are working in translating some data sets in English into Spanish. It's a bit more difficult than we expected because physicians use a lot of abbreviations and acronyms, and sometimes they use the same acronym to refer to different things. So the poor language models is getting crazy with that, but we're working on that in order to also provide these models into Spanish and Chile, of course.
Any more questions?
Hi, thanks for the talk. At least in France, it's a bit of the bottleneck is that it's really hard to collect the medical data because of its sensitive data, and it's comprehensible that it's a matter of privacy. So what's the policy in Chile? Is it easier to get the public data?
No. No, one thing that makes it difficult first is that we don't have an integrated system. In other countries, when you have the information of one patient going to one medical center, there is a centralized system where you can get information from that same patient from different places. Here you have, or in the public system, or in specific clinical centers, you cannot collect it, you need to talk to each one. And also each one is going to have their own policies regarding privacy. There is a good data regulation in Chile about protecting the data of patients, but that also sometimes hinders in the case that you want to do research. But I completely understand that is the right way to protect patient data. So no, it's not that simple. But if you go through all the channels, like the ethical committees here at the university and at the specific clinical centers, you need to be patient, but then you can get the data in order to get it and train models. But then another thing is to make it public, because you need to make sure of all the privacy, removing entities, names that recognize private data, also maybe running some differential privacy stuff. So it takes time, but it's an issue too.
Okay, let's thank Dennis. Okay, so the second talk of the session is by Luis Martí from Inria, Chile, and the title is Explainable AI for Understanding Plankton Communities.
Thank you very much. Good morning, buenos días, bonjour, buongiorno, guten Morgen, dobre utram, konnichiwa. So today I am going to present part of the work we are doing related to how, let's say, apply AI to understand and mitigate climate change. This is a very big problem, no? It has many different aspects. And here we're going to present a subset of these results. In the rest of the Journées Scientifiques, we are going to have more papers, more presentations related to this topic, covering different aspects. And also we have a keynote on Wednesday, if I am not wrong, where we will have time to go in more broad details. Today we are focusing in the particular case of plankton image identification and the nuances that it has. So probably you will have to be, I would say, under a rock, but not even under a rock, to hear about the problem we are facing related to climate change. So here there are a couple of interesting, this became like a trending topic of how to plot the variation of average temperatures. Every time I see this, I remember when I came to live in Chile, the person renting my apartment told me that you don't need air conditioning in Chile, and actually the plot shows that you do. No? Maybe in the 80s not, but recently. And if you are like me that prefer accesses and values, this is the evolution of temperature globally in the last 100.5 years. And this is, by the way, year 2023, that is a record hot year. So this is a problem that obviously is affecting, is already in motion. No? And it has a lot of implications. First, on biodiversity. Biodiversity is not only affected by climate change, there are other factors. We kill a lot of animals, etc., and cut a lot of plants, but climate change is part of this problem and has many other impacts, you know, catastrophes and the changes in the agriculture, production patterns, and all of that. So it is only natural that we try to address this problem using AI because, you know, AI is obviously, let's say, a go-to tool when we want to create any sustainable economy solution, because normally these more sustainable solutions tend to be more fragile, so you need AI to keep a tight control on the, let's say, production loop, or you need to optimize some processes, etc. So there is one first case where AI can help us in climate change. Then AI is essential to understand climate change itself. It's a data problem, so we need to apply these methods. And then there is a third leg to this, that is that AI itself is becoming a climate change issue. I mean, computing in general, but AI in particular. There are these forecasts that for 2030, half of the electricity consumption of mankind will be dedicated to information technology. Therefore, we need to be careful and we need to look at this. And, well, it is an ongoing problem with, let's say, ongoing solutions. No? In any case, it's a very important problem. That is already, by the way, is already affecting us. Just a little data or a little fact, social networks produce more CO2 than the airline industry completely. So when you use TikTok, you are polluting, you should travel, no? I don't know. So we have this three-way situation. Today we are going to focus on the box in the middle. We are going to focus on how we can understand climate change and hopefully mitigate it. But this is not the only thing. In particular, well, Inria in general, the institute is heavily driven towards this kind of problem, but in particular in Chile, we have been addressing this in different projects. I don't have the time to go over them. Some of them, actually, Antoine was involved when he was here before. Antoine, I use this slide all the time. I did it especially for you. So it's we have been heavily driven to this kind of problems. Hernan is going to present the work that we have on autonomous sailboats, etc. There are a set of these problems. Probably the project that has the highest amount of attention, and the biggest one is this project that we call Oceania, as Ocean and Artificial Intelligence. And it's a project that, as you guys try to find what is the case of AI for understanding and mitigating climate change. So the situation is, why the ocean, no? Why are we focusing on the ocean? The first thing is that the ocean is our, let's say, the main mitigator for climate change for two reasons. First, it's a lot of water, so if you want to change the temperature of water, you require a lot of energy, so the ocean works like a physical blanket, no? And then in the ocean, there are a lot of organisms, in particular plankton, that capture CO2, and actually the ocean is the main area where CO2 is removed from the atmosphere. We tend to identify, for example, the Amazon, all of that. Actually, it's the ocean who captures the most amount of CO2. But then climate change, that is already in motion, is destroying this healing capacity of the ocean. It's destroying ecosystems, so this means that it's not only we are going bad, but we are going bad at an exponential rate. So we need to try to identify and have a solution for this problem. So we have three really big questions. One is try to understand explicitly and precisely how the ocean actually mitigates climate change. For example, this implies understand what ocean ecosystems are the ones that capture CO2. Not all of them capture CO2. Some of them actually generate CO2. No? So we need to identify and quantify how this process happens, and then we can move to a scenario where we understand how the ocean is going to change. For example, if we increase the temperature of water 2 degrees, some currents will disappear. There is already some predictions. For example, the Gulf Stream that goes from Florida, Bahamas, all the way to Norway, that thanks to that, Europe is livable, more or less. The weather in Europe is milder than in Canada or the US because of this. It's probably going to disappear. So there are a lot of these scenarios. And hopefully, at the end of the project, this is a 5-year project, we are at the 1.5 or almost 2 years point now, we want to have some proposals to take to decision makers and to say, okay, if you do this and that, you can improve the situation. If you protect these ecosystems, or maybe do like a dynamic ecological reserve that you can move in the ocean as different ecosystems are moving, etc. We could have meaningful solutions to this. Don't worry, I will not explain this. This is to tell you that we are doing a lot of activities, in part because there are different sources of information. There are plankton images, satellite images, genomic data. Then there are a lot of tasks related to modeling, because as the ocean is water, things are moving. So it's not only, I remember, I'm going to quote Pablo Marquez saying that if you go to a savannah to study the lion is going to be there the next day, no? But in the ocean, it's moved away to another. I don't know if Pablo is here. Say hi. No, he's not. So we need have a lot of modeling tasks. So I will be focusing on, in this presentation, in the task of identifying plankton using vision, because we have a, let's say, a broad-reaching goal here, no? Ideally, we want to go from satellite images to ecosystem identification. So this is challenging because, of course, if you want to identify plankton using satellite images, sounds, I don't know, let's say, illuminated, to not say another word. But actually, it is possible. Actually, some subsets of these problems have already been discovered. So we want to focus right now in the task of consuming plankton images. And why? It's because there are different oceanographic expeditions. In particular, we are associated with Tara Ocean that has been traveling and doing these oceanographic expeditions for the last 15 years, gathering a lot of data. They essentially gather two types of information: genomic sequences, so they take samples of water and sequence this information at different depths and all of that. We can talk on Wednesday with more time about this. And they also take a lot of plankton photos. So to give you an idea, in this Ecotaxa website that hosts all this information, not only from Tara Oceans, but also from other expeditions like the Spanish Malespín expedition, all of that, they have a data set of 220 million images. Of them, more or less 4 million are tagged as living and with an associated organism species, and then 8 million are tagged as non-living. Actually, this is important because these non-living photos are meaningful because these dead individuals that are slowly flowing towards the bottom of the ocean is how carbon is sequestered and converted into rocks and all of that. So it's important not only to know what individuals are living, but how much, at what rate they are following. And by the way, this is another task that the colleagues of BioCore are in Inria, of the BioCore team, are looking at this. So we started to focus on the problem of plankton identification and try to, let's say, move more into frame the problem as a machine learning problem. And for example, when we started to do this, these are the two main or biggest data sets available. SUSCAN, that is a subset of Ecotaxa that has been curated and all of that. You can see and notice that it's not clear in the figure, but the scales are logarithmic, so there is a heavy imbalance in the data set. There are a lot of classes that are heavily represented and a lot of classes that are very least represented. To make things even more complicated, the most populated classes are bad or mixed, or because remember, this is a photo. You cannot take the plankton to pose for the photo. It's actually photos taken at different. So some of these photos are part of other things and all of that. So we have a problem now. We are moving closer into the machine learning area. we have right now we have worked with 4 different data sets. These are the most challenging ones, the biggest ones. But we already see that there is a problem. There is a problem with a heavily class unbalance. What we have done is, okay, the first trivial step here is to try to go supervised learning, you know? There is, and here Dennis already gave me a lot of cover introducing a lot of these models. We have used the state-of-the-art image transformers and some not so state-of-the-art approaches, but still, you know, convolutional neural networks and all of that, and apply them to try to classify plankton. So for example, these are, by the way, we try to apply all the methodological tricks we could see around and do some sort of AutoML to find the optimal combination for, you know, let's try to see how far we can get doing plankton classification. And again, and this is, I forgot to mention earlier, but this is a very important leitmotif of the whole project, and this case in particular. We don't want just to do a plankton classifier. We want to help biologists to identify species and to have a research tool for them. So explainability is a key issue. So you can see here, for example, how different models classified the same organisms, and you can see, let me see if this works. This guy here was correctly classified, but the neural network and the heat map says tells where the neural network is focusing at. Then it showed similar photos, but for in the case of radiology, you can see that in this case the neural network is looking at the wrong places. So if we show to a biologist, okay, I classified this, and I use this information, for example, it's using the corner of the image, no? The biologist can tell visually that this is a meaningless classification. In return, you can see that in this case, this neural network is focusing on this structure of the organisms here, but not focusing on this bubble that you see around here. This is very important because we want also to avoid all these classes of biases and all of that, and to make sure that the models that we are creating are classifying the elements in the image that are really meaningful. So this is a first step. We are right now in the state-of-the-art of plankton classification. There is not a lot of competition there, but we are. Actually, we need to write papers, but this is. But then once we hit this, we say, okay, how can we take this even more forward? How can we move forward? And the good thing of biology is that there are a lot of people working here for thousands of years, literally, and one of the things that they have is that this is not just a classification problem. There is a hierarchy to this. Organisms belong to these taxonomies, so if we use this information, maybe we can help the network to classify images in a simpler way. So it's not the same to have an image and determine the species of plankton than to have an image that I know that is a living thing that belongs to the prokaryotes and all of that. I don't remember the rest of the levels of the tree, but it's simpler to do that because your scope of decision is more reduced. And also, by the way, you solve a little bit also the class unbalance because you are looking at different subtrees and we saw that they tend to be less unbalanced like that. So here we apply different, let's say, the state-of-the-art of hierarchical classification. And we had an intern from Jean-Baptiste at that time, and he wanted to do a new neural network, you know, because just the experimentation was boring. And we worked and proposed a new approach that tried to split branches between living and non-living and all of that. So these are the results. I'm sorry for the long table, but essentially what we can see is that if we go to different levels, this is like the performance of the neural networks across different levels. But the most important result is that when we compare with this with our, let's say, when we compare the performance of these neural hierarchical classifications against the non-hierarchical one, in most cases, in all cases, we had better performance. And then our new neural network actually didn't perform amazingly good, and we need to work more, so not all results are amazing, no? Then there is another problem, that we have a bunch of plankton species that we don't know. Actually, if you saw, we took from 220 million images, a subset of 4 million. Actually, SUSCAN is even less than that, it's 1 million. So what happens when we see a new plankton image? And this is very important, it's connected with what also Dennis was explaining before me, is that we need to be ready to be answered, I don't know what this is. So the third step in this process was to try to identify out of distribution new plankton species that didn't were in the data set. So there are many approaches to do this. This is an area where I am particularly, let's say, passionate about. One of the approaches that we can follow is to try to pick at the output of the classifier. Neural network classifiers, I would say 99% of them, just to leave 1% for exotic cases. They have an output that express at some level the probabilities of the input to belong to one of the classes, no? So if we look at this activation of the final layer, and we see if everything is working normally, we see something like this. There are many classes that has like very low probability, and one class that has very high probability. But in some cases, something like this happens, and the network is telling us, I don't know. What happens is that then we normalize this and we destroy this information and actually make these things different. But we need to identify this flat nature of the activation that the neural network itself is telling us, hey, I don't know, you are trying to make me classify something I don't know. What happens is that, and this is when we did that in the naive way, we have a 58% of recovery of out-distribution elements. So, and this is the work also with our team, with an intern, Benjamin, from Universidad de Chile. And first we were trying to apply, let's say, the state-of-the-art of out-of-distribution detection using a committee of decision and all of that, as we tend to do in machine learning in these cases. And Benjamin had this idea of, okay, what we can do is to show true out-of-distribution elements to the network and force the activation of the network to be flat. So the network will learn to tell, I don't know. So we did this with a data set that looks natural because it's flowers, still it's very different, and we managed to increase the recovery of out-of-distribution of unknown plankton species to 93%. Right now, you know, there is this new wave of AI, and we are doing this using generative AI, asking, you know, the model to generate plankton images, and they are even more confusing and harder to deal with. So thank you very much. I think I managed to finish more or less in time. Yeah?
Thanks. Time for questions.
Hi, is it possible to take advantage of having metadata such as the depth of the sample or the geographic coordinates of the sample or things like that?
Yes, actually, this is a plot we drew. Actually, no, I have to say this is from the website, but we have this in another slide, sorry. All this information is not, you don't only have the images, you have all this metadata, the depth, the temperature, the salinity, and actually there is a very good opportunity of doing, I didn't have the time to focus on that, or what Dennis was commenting before, because we can create a multimodal approach to this, because we also have the genomic information that we found in that place. So it's like you have a lot of photos, and then genomic sequences that were recovered at the same place. Yes. Actually, Luis is presenting tomorrow some of the work that consume all this metadata and all of that.
Hi, thank you. Thank you very much. I'm a marine scientist, so I'm very pleased to see the progress. And
oh, no.
just the same way, no, it's good because I know a lot of work done in Europe, European project funded on the digital twin of the ocean, focusing on collecting different type of data, and I know images are part of those plans, so I will connect you to these people. But the same way, not only you can connect genomic data, but also all the hydrogeographic, chemical data, because at different depths you will have these characteristics, and these are also based ISO Copernicus. There are many geographic, how do we say, oceanographic data that can be also mixed together to obtain a better, accurate relationship. But it's good that there is this work, because we do not have any more taxonomists in marine sciences, so that's a good work.
Thanks. Well, I always say that we are holding like only one leg of the elephant, because actually, for example, this is a true, in this plot, this is Tara, all the stops that Tara did when traveling from Lorient to Punta Arenas. Actually, they generated a lot of data, they have millions of images, but you see, they stopped, I don't know, 40 times, maybe. So actually, to cover the ocean, we need to incorporate different sources of information, all of that. And for example, try to reuse the knowledge we already have from other domains, like, let's say, land biology, because proteins have the same function, and try to extrapolate from that. But it's and then, just to talk to the machine learning crowd, this is also a very challenging problem because of this nature. You have a lot of data, but in very few points. It's like having an Excel with a lot of columns, but very few rows. So doing machine learning like this is not trivial.
Well, let's thank Luis.
Thanks.
This one. What I have to do then? This is my slides. I'm not a Apple guy.
Okay, so the third speaker of the session is Frédéric Semet, and he's going to talk about modeling buyers' behavior in logistics and e-commerce. Thank you.
Thank you. So first of all, thank you very much for the invitation. It's really a pleasure to be here. And what I am going to present today is part of the research project which was carried out by our associate team between Chile and France. In fact, we have now for a number of years a very strong collaboration with many universities in Chile, and mainly with here in PUC with Vladimir Maryanov, with Fernando Ordonez in the Universidad de Chile, and with our team. Our team is the INOX team in Lille, and it is a joint team between Belgium and France. So we have a Belgian researcher. So this associate team is really international. Martin Labbé from ULB, and myself from Central Lille. So this is I put some example of the research we carry out on this very general umbrella about modeling buyers' behavior. And I would like first to motivate this talk, and then I will give at least one example, which will be the product line optimization. If I have some time, I would just say a few words about buyers coalition, and then some conclusion. So, in fact, assume that you want to buy a washing machine, for example. So you go to this type of store, and in this type of store, you have already a very wide range of choice. You have various washing machines with different properties, with different specificities, which can be the brand, the color. Here they are all white, but you can have inox washing machine, and so on. And if you go to internet, you have even a larger range of choice. On the other side, if you are a retailer, you own a chain of stores, you have exactly the same problem. If you want to display all the washing machine in your stores, you can't. You have a limited space, so you want to select a good subset of washing machine which could be of interest for your customers. So for a retailer, it's very important to know which product he is going to display. So he has to face many questions. The first one I just mentioned, which products display. Then he has to know what will be the product prices. In fact, he can, depending on the area, on the customer, he can set different type of prices. He can offer discount or not in a given area at a given store. So he can have different prices, and maybe he would like to define bundles of product. If you go to right now on Amazon, typically you select a product and you will see at the bottom of the page they are going to propose you other products. And they say, well, people who buy this product, usually they buy also those products. You can do it like in this way, but you also can define bundles of product and say, okay, this bundle of products could be offered to you at a good price if you buy the washing machine plus some insurance plus some additional products and so on. So what we have addressed in this specific context is knowing this type of question for the retailers, how we can model the customer behavior to answer as in the better way those questions. What we do in logistics and in transport optimization these days is the following. In fact, all forecasts are totally separate from the optimization part. So on one side, you have the forecast, which can be long-term forecasts to short-term forecasts, depending on the problem you are addressing. These forecasts are based on some data coming from the system, but on the other side, we optimize the system, so we design algorithm and methods to take decision in these different contexts based on this forecast. And those two things are quite separated. There are some exceptions, I will mention them at the end of the talk, but basically those are two different domains. What we have done in this associate team, we have tried to integrate the demand forecast, the customer behavior within our decision-making process. So let me turn to the first problem, which is the product line optimization. So this was part of the thesis of Sebastian Davila. And in this case, we have considered a firm, and this firm has several stores. and he has a large set of mutual substitute products. What I mean is, in fact, I have products on the same time. Let's take washing machine, and those washing machines have different characteristics. And to display these washing machines, these products, you have a limited space. So you are going to select among all those products a subset of products to display. On the other side, you have the customers. And the customers are around different stores. They are located geographically speaking. They have preferences, and we assume that each customer is going to purchase only one item. So we are on these items a little bit strategic one, those with such as I mentioned before, TV sets, washing machine, and so on. So the problem of for the retailer is which one to choose at each store. This is what is called the product allocation problem. But more than that, he could use a markdown strategy. What is new in this problem is this problem has been studied for a long period now. It's not a new problem, but here we do something quite different comparing if we compare to the literature. We integrate the pricing and the allocation problem, so the pricing of the products and the allocation of the product to the stores. We take into account the fact that each store has a limited capacity, limited space, and more than that, we can take into account that the fact that the store have different demands. So in fact, we modeled this problem as into a new setting, which is a two-player game. We have two players, the retailer and the consumer. And how we are going to model the behavior of the consumer, in fact, what we are going to do is we are going to model the reaction of the consumer according to the retailer decision. So the retailer acts as a leader of the problems, if set the products which are displayed in its stores, and the consumer is what is called the follower. He is going to react to the decision of the leader, and this is typically what is called a bi-level problem. In game theory, this is related to what is called Stackelberg games. So let me just introduce some definition. We have a set of stores, which is capital G. We have a set of products, capital K, and we have a unit price for at a store for a given product. And the objective of the retailer is basically to maximize his profit, and for each store he has to select at most a number of products. So we say that he has a limited space, so this limited space turns to be a limited number of products. And for the customers, they are interested in a subset of products. They are not interested in all products. They have what is called in economy a reservation price. This is the maximum price they are ready to offer for a given product. So this reservation price is the maximum price the customer is ready to pay. And you have some transportation costs. So we take into account the fact that the customer has to go to the store, so it is going to cost a certain cost. So we can define a utility, which is the difference between the reservation price, the price of the product, and the transportation cost. This means that given the set of product he is interested in, we can define another set, which is the set of product for which he has a positive utility, so which are really of interest. And this set is a set of product and location. And basically what the customer wants to do, he wants to maximize his utility. So just to give you an idea of the type of problem we address is this type of problem. I don't know if this will work. Yeah, I'm not sure. Yeah. So in fact, we have the leader problem. It's a very simple problem if you take it as it is right. You have to decide which product you are going to display in which store. Okay, the product J is a store. So you are going to decide which product you are going to display in which store. The maximum number of product is this PJ. So you have only one constraint for each store, and you want to maximize the profit. The trick is that the profit depends on what the customer decides. So if customer I decides to buy product A, product K in store J. So in fact, here you see you have an optimization problem with y variable, but the objective function does not depend on the y variable, but on the x variable. And how do you obtain the x variable? So the decision of the customer by solving another problem. This is the problem of the customer. He wants to maximize his utility. He is going to select only one product. The product has to be present in the store, for sure. So this is the problem of the customers, but you have to solve this problem. But this problem depends on the y variable, the decision of the leader. And if the leader takes his decision, this model the reaction of the customer to the decision of the leader. So given the y, he is going to react to maximize his utility, so to set the value of x variable as set, and then this gives the profit of the leader of the store chain. So this is not solved like this. It is not a sequential problem. This is an integrated problem, and you have to solve it as it is, not moving from one solution to the other. Everything is solved jointly. So hopefully there is a trick here. In fact, you can define those sets which are called preference sets, and those preference sets are just sets which say, okay, if I take the given product for our customers, this set contains all the pair products location which are preferred to this precise pair of product store. And if I define this set, I obtain this problem, which is simply mathematical programming models with binary variables, which can be solved more easily. And this is exactly what we have done. We have developed some what is called valid inequalities. So we try to strengthen the model by adding new constraints. I just give you here an example. In fact, we can define constraints which are not present in the definition of the models, but which strengthen the model. This means that you see we have two customers, I prime and I. This is the set of this is the preference set of I prime, which is included in the preference set of I, and we can have this inequality. What does this inequality means? This one is very simple. In fact, if customer I select the pair JK, in fact, there is no better choice for I prime. The preference set of I prime is included in this preference set of I, so there is no better choice for I prime than selecting exactly the same pair product store. And we developed some algorithmic approaches. So we design our optimization method, and we implement them, and we obtain some numerical results, which are the following. I just take this table to show you what type of results we have. So here we have 12 stores. The capacity of each store is 10, and I is the number of customers, so going from 100 to 400, and K is the number of products going to 20 to 80. When I'm talking about customers, these are not necessarily individuals. Those can be what is called segment of customer, which means customer having exactly the same behavior, same location or same area, and same reservation prices. So with this cut and branch approach, we are able to solve, each time we have 5 instances, we are able to solve quite large problem, except the small ones, and we are very competitive with this approach. This approach was proposed some years ago by people from MIT, and you can see that we obtain better results in shorter computation time. So how long I have? 2 minutes. So let me just tell you a few words, just one slide about the buyer coalition formation. We address another problem, which is the buyers coalition formation, and this is related with what is done in companies like Groupon. In fact, you have a retailer which define bundles of products, and what is interesting here is the product prices depend on the total quantity purchase and not on the individual quantity. So you don't have a fixed price, but depending on the number of customers you have, the price of the products decrease. And in the problem we address, each buyer buys at most one bundle, and we solve this problem, the problem of the coordinator, which is exactly what Groupon does. In fact, it tried to identify coalition of buyers, so group of buyers which are going to buy exactly the same bundle in such a way that this maximizes the surplus, which is again the reservation price minus the total product price. So this coalition, you have to define which set of buyers you are going to assign to each bundle. So to conclude, I would just, I would just want just to say that there is a clear need for better modeling the customer behavior, especially in logistic models. There is some preliminary works, but several research avenues exist. Clearly, one of them is bi-level programming, because you can model exactly the reaction of the customers. There are other approaches, stochastic programming, which has been addressed for a long time, and 2 other more innovative approaches which are of interest. The first one is to integrate in the optimization model the demand forecasting models, which can be of different nature. And the second one, which has been already addressed in some cases, is to integrate what is called discrete choice models in optimization models. Thank you for your attention.
Thank you. Time for questions? Any questions? questions? So can I ask something? Is your problem hard to solve?
Yes.
Okay.
In fact, what is different, but in general, bi-level programming is even in general, generally speaking, bi-level programming is sigma to sigma to p, yes. So they are very. Even if you have some new machine, quantum machine, this problem will remain quite challenging to solve. Yeah.
Any more questions? Yes, Luis?
Hello. You mentioned about incorporating, let's say, the interest of the product or the demand of the product, no? In the sense, because we don't buy in a rational way, no? And that is why Amazon tries to suggest us to buy more stuff that we don't need. How does it get in your model, in the optimization? Like, how can we incorporate this demand that we are getting from society, or like a forecast of this demand?
I'm not sure I get your question.
So
I do not hear you very well.
Okay,
So
maybe if I like this. So how do you incorporate demand or interest in a product into this, into your optimization problem that you are assuming, let's say, a certain rationality of the market, that people buy what they need and you offer them at the best price you can offer? How? Because, I mean, I don't know, these luxury brands, how could they get into the equation when people buy more expensive stuff just because?
in fact, what we do is we model in our optimization model, we have an optimization model which exactly models the reaction of the customer. So, but indeed, this model is based on reservation price and so on. So I don't know if this answer to your question, but this is the way we do it. So we have an optimization models, and this is the same with if we have demand forecasting. What we want to do is we have within the optimization models, among the optimization models, we have different demand forecasting, and we optimize on the decision variable, but in this it's taking into account the different forecasts we have for the demand.
Well, let's thank the speaker. Well, I'm the last speaker of this session, so I'll introduce myself. I am Pablo Barceló from the Institute for Mathematical and Computational Engineering at Catholic University, and I also work at IMFD and CENIA. And I'm going to talk about SHAP's course and its computation over machine learning models. So, what is the flavor of the explainability problem that I'm going to study in this talk is the following. You're given a Boolean model. What is a Boolean model? It's a certain model that receives as input a vector of zeros and ones and produces as output a 0 or a 1, right? So it's a Boolean machine learning model, but this model can be anything, right? It's just a function from zeros and ones to 0 or a 1. So the question, one of the fundamental questions in explainability is how can we explain the output of this model on this input, and this vector of zeros and ones that we're given as input, why the output of the model is 0 or is it 1? And the the kind of Boolean machine learning models people have looked have studied for these problems are linear models such as perceptrons, decision trees, binary decision diagrams, BDDs, which are a generalization of decision trees, and much more in general Boolean circuits, and of course neural networks, which are multi-layer perceptrons. So the folklore claim says that models such as linear models or perceptrons, decision trees, and binary decision diagrams are easy to explain or even self-explainable, while neural networks, multi-layer perceptrons, are hard to explain. For Boolean circuits, it really depends on the kind of circuit that we are considering, and I'm gonna try to talk a bit about that during the talk. And I'll try to challenge this view a bit that some things are very easy to explain, right? So that depends on the kind of explainability query that we are trying to study. So the kind of explanations that I'll be studying are local explanations. And local explanations are how can we explain the output of the model on a given input just by looking at the input and the model as a black box. And what do I mean by the model as a black box? It means that we only have access to the model in terms of its input-output behavior. We don't have access to the internals of the models. We are not trained in the model. The model has already been trained, and we can witness how it behaves. Yeah? So several queries and scores have been proposed to capture local explanations. For instance, minimum change required. Minimum change required is a notion of how robust a model is with respect to a certain input. So the question is, what is the minimum number of features we need to flip in our input in order to change the output? This is a why not question, right? Why didn't we get the opposite answer from the model? But there is also the why yes question. Why did we get this output? And this relates to the query of minimum sufficient reason, which says, what is the minimum subset of the features of the input X that suffice to obtain this output? That is, the output of the model is invariant to all the rest of the features. We would get the same output regardless of how the other features are interpreted. And finally, the SHAP score, which is the score that I'll be looking in the next slides, which is a game theoretical concept for capturing the contribution of each feature to the output of the model. Yeah? So let's look into the SHAP score a little bit more in detail. So as said, we have an input X, a vector of zeros and ones, and we want to measure the contribution of each feature, X sub I, to the output of the model on this input. So a basic idea here would be to measure the difference between the output of the model in this input X and the expected value of the model M on all perturbations of the ith feature, right? That is, we would take the difference between the output of the model on X and the expected value with respect to some probability distribution of the output of the model on every input Y that coincides with X in every feature, save for the ith feature, the one for which we are measuring the contribution. So the problem with this is that it's not really a good measure when features interact with each other. And I'll try to give an example to convey that. Let us consider a very simple Boolean model. This Boolean model only takes the disjunction of two variables, x1 and x2, of two features. And we're given the input that assigns a 1 to each one of these features. Then, under this notion, the contribution of each feature in the input to the output will be just 0, because if we perturbate one of the features and we change it by a 0, the output of the model will continue being 1, right? So if one of the features changes to 0, we will not be changing the output of the model. And of course, this doesn't correctly measure the contributions of the features in the input to the output of the model. So the conclusion is that the contribution of a feature should be measured in terms of how such features interact with each other. So let me try to define what this idea of the SHAP score is. So the idea is the following. We are given a set of features, x1 to x sub n, and we are given an input. An input is nothing else than an assignment of the features to values in 0 and 1. That is an input to the Boolean machine learning model. And we are given some probability distribution on the set of all possible entities, on the set of all possible inputs. So given a subset of the features, S, the expected value when features from S in the input E are known is precisely that, right? So it will be the expected value of the output of the model on every entity E prime that coincides with E exactly in those features that are in S. That is, I unveil all the information in the features from S, and I can change the rest. That will be the expected value when features from S in E are known. And the idea on how to correlate features to understand their contribution comes from a paper by Strumberg and Kononenko in 2010, which says, we are going to try to define recursively the contribution of a set of features S to the output of the model. First of all, the contribution of the empty set to the output of the model is simply 0. And then the sum of the contributions of every subset of S is really the difference in expected value between knowing S and knowing nothing, which is this delta there, right? So it's the difference in expected value in the output of the model once all the features from S are unveiled. This difference in expected value is fully explained by the sum of the contributions of all those subsets of features in S. And then the contribution of a single feature, x sub I, is a weighted average of the contribution of x sub I to each subset S. So it is the score of the contribution, the contribution score of feature I to the output of the model on input E is the sum of the contribution of S union x sub I divided by the cardinality of this set. So now, what Strumberg and Kononenko discovered is that there is a simple explicit description of what is the contribution score of I in terms of a model. It's the sum of the difference between knowing or not knowing the ith feature for every subset S of the features, weighted by this expression that depends on the set S and the number of features N. But once they realized this, they noticed that there was a strong connection with the idea of a Shapley value. Yeah? And the idea of a Shapley value comes from game theory and economy. So in Shapley values, what we have is a set of players, n players, P1 to P sub n, and we have a reward function that for each set of players tells us the value of the contribution of the coalition of this set of players. And the Shapley value of some player under this coalition is an expression that looks exactly like the one that Strumberg and Kononenko got, right? Only that instead of having the expected value in terms of the function nu, we have nu itself, right? But this tells us that we can see the contribution of score of a feature as a Shapley value in a game. What is the game? The set of players is the set of features, and the coalition function is nothing else than the expected value of the output of the model on input E when the features from S are unveiled. So this tells us that we can simply call the Shapley value or the Shap score of the ith feature with respect to the model M on input E. This will be the contribution score of the ith feature, right? And that's a relation that exists between these Shapley values, these Shap scores, and the contribution of each feature defined in this recursive way in which one defines what is the contribution of a set of features to the output of the model. So this was our starting point, and given the needs that people were having to compute these Shap scores, we wanted to understand what was the complexity, the computational complexity of computing these Shap scores over different classes of machine learning models. Sorry, before that. Example of a Shap score, I'll not get into detail, but for the same model that we had before, now the contribution of a feature is no longer 0 as it was for the initial definition that was wrong. But in this case, the contribution of each feature is the same, but it's positive, and it's 1/8. Yeah? So that shows that at least the idea of the contribution of a feature is going in the right direction once you have these Shapley values or Shap scores. All right, I have to take my own time here. So in terms of the computational complexity of the Shap score, what happens here? Imagine that we have a Boolean model M, and we define SAT of M as the set of all inputs to the model whose output is 1, right? This is the set of satisfying assignments for the model, yeah? The set of positive instances. And then counting SAT of M, as it is defined in the second line there, is nothing else than the cardinality of this set. How big this set is, how many instances are there for which the model classify these instances positively. And a very simple observation is that for a Boolean model, M, the number of satisfying assignments for the model can be computed in terms of the Shap score. So if we know how to compute the Shap score for the different features, we can identify in polynomial time how many of these inputs are positive. And this immediately tells us that computing Shap scores is computationally hard, yeah, unfeasible, essentially, for every class of models for which it is hard to count the number of satisfying assignments. And we know several of those models. So for instance, linear models or perceptrons, which are considered to be easy to explain, computing Shap scores for these linear models is computationally difficult. Yeah? So it's unfeasible. And very simple Boolean circuits, like formulas in disjunctive normal form, in which all literals are positive and there are at most 2 literals per clause, it's difficult. Yeah? Okay, I have 5 minutes. That's a negative result, right? So in many cases, computing sharp scores for models of interest in practice is computationally very expensive. Yeah? However, there are well-behaved Boolean circuits. These are Boolean circuits for which the problem of counting the number of satisfying assignments can be solved in polynomial time. And these are called the deterministic and decomposable Boolean circuits. So let me recall briefly what is a Boolean circuit. A Boolean circuit is nothing else than a directed acyclic graph in which the leaves of this directed acyclic graph are labeled with variables or constants. The inner nodes are labeled with Boolean gates, that is with negation, disjunction, or conjunction. And there is a single gate labeled as output. So an entity satisfies this Boolean circuit if it satisfies the Boolean formula that naturally defines the directed acyclic graph. So what is a deterministic? This is a Boolean circuit, but what is a deterministic and decomposable one? A deterministic and decomposable one has to satisfy certain properties. For being deterministic, we have to have that each time that we have a disjunctive gate, such as the first one, then there is no assignment that satisfies the left-hand side circuit and the right-hand side at the same time. Yeah? So this means that when we count the number of assignments, of satisfying assignments, then we can count the ones on the left and the ones on the right, and we don't have to do inclusion-exclusion. And it is decomposable if every time that we have a conjunctive gate, then the variables that come from the left are disjoint from the variables that come from the right, that give us a similar good property. So this is an example of a deterministic and decomposable Boolean circuit. For instance, the AND gate at the top, the variables that come from the left is just the singleton X, and the ones that come from the right are Y, Z, and B. So these are disjoint, and it satisfies one of the properties. Now, why deterministic and decomposable Boolean circuits are important? Because several important Boolean models applied in machine learning can be translated in polynomial time into these circuits. And these include the well-known class of decision trees, the ordered binary decision diagrams, OBDDs, the free binary decision diagrams, etc. So if we prove good properties for this class of deterministic and decomposable Boolean circuits, then we prove them for all these machine learning models at once. So since I have only 1 minute, I'll give you our main result. Our main result says the following. Sharp scores can be computed in polynomial time for this class of Boolean circuits under the uniform distribution on entities, but in fact we can extend this to more general distributions. For the class of decision trees, for the class of OBDDs, for the class of free binary decision diagrams, and for the class of deterministic decomposable negation normal form circuits. Why? Because we can compute them for these deterministic and decomposable Boolean circuits in polynomial time. Yeah? Thank you.
Any questions?
People are hungry.
Well, we thank Pablo Barceló for his presentation and for sharing the first scientific session of the conference. And now we invite you to move to the hall where lunch will be served at 2 p.m. We will reconvene here. At 2 p.m. we will reconvene here to begin the first round table of the event. Thank you very much.